In this video, we're going to look at log laws. In previous videos, we've already seen two of them. For a, where a is a positive quantity, we can say that log to the base a of a is equal to 1. Let's just remind ourselves of the definition of a logarithm. The logarithm is the power the base is raised by to give a certain value. So if we write the exponential equivalent, a to the power of 1 is equal to a. We also saw that log to the base a of 1 is equal to 0. We know a to the power of 0 is equal to 1, therefore log to the base a of 1 is equal to 0. We're now going to focus on three more laws. The first one is log to the base a of x plus log to the base a of y is equal to log to the base a of x, y. So if we're adding logs when the base is the same, so in this particular case the base is a, if we're adding logs we end up now with a product. The next one, log to the base a of x minus log to the base a of y will be equal to log to the base a of x divided by y. So if we have a difference, this becomes a quotient. So if we're subtracting, we end up dividing. If you're ever struggling to remember these, just go back to the rules of indices. If we're multiplying and the bases are the same, we add the powers. If we're dividing and the bases are the same, we subtract the powers. So therefore, this is just working in the opposite way. If we have now the third one, log to the base a of x to the power of k is equal to k multiplied by log to the base a of x. So these now are three particular rules that you will need to learn and apply to certain problems. Let's just look at these first two. What I'm going to say now is the following. I'm going to define now log to the base a of x to be equal to some quantity p. So if we write now p is equal to log to the base a of x, and we say that q is equal to log to the base a of y. If we now write the exponential equivalent, we can say that a to the power of p is equal to x. So just writing this out, a to the power of p is equal to x. If we write the exponential equivalent, we can say a to the power of q is equal to y. If I multiply these two, a to the power of p multiplied now by a to the power of q will be equal to x multiplied by y, or xy. Using the rules of indices, we can see a to the power of p plus q will be equal to xy. I'm now going to write the logarithmic equivalent statement, and that is that p plus q is equal to log to the base a of x, y. If we just consider now, we have p plus q. P is log to the base a of x, q is log to the base a of y, therefore we can see p plus q will be equal to log to the base a of x multiplied by y. So let's just go ahead and write that. So we've got p plus q, so that's log to the base a of x plus log to the base a of y is equal now to the product of log, well it's log to the base a of the product x, y. And as you can probably imagine, this works too for subtraction. If at this stage instead of multiplying we divided, we could say that a to the power of p divided by a to the power of q was equal to x divided by y. If I now consider I've got the base the same using the rules of indices, we could say a to the power of p minus q is equal to x over y. Now rewriting the logarithmic statement, p minus q will equal log to the base a of x over y. So we can see now the subtraction p minus q is log to the base a of x minus log to the base a of y, and that's going to give us log to the base a of x divided by y. So let's go ahead and write that. Log to the base a of x minus log to the base a of y will be equal to now log to the base a of x over y. So that shows now that those hold true. So these now are additions for, or are rules for addition and subtraction of logs. If we add logs when the base is the same, we end up with a product. Now you might want to just write this. You might want to write log a plus log b is equal to log ab. If you want to just remember it like so, this is perfectly fine, as long as the base is the same. And we can say that log a minus log b will be equal to log, and then we'll have a over b. So those are two rules that you need to be able to use. The rules for addition and subtraction. Okay, let's look at this one. Log to the base a of x to the power of k is equal to k lots of log base a of x. So log to the base a of x multiplied by k. Now we can show it with a very similar approach to the one I've just used, and using the rules of indices. I think this is easier to show it in a more intuitive way using these particular laws. So what I'm going to do, instead of using now a similar approach to show a proof of this, what I'm going to do is take an example. If we have now, let's say we've got log, and we will have log, and I'll just use now log rather than any base. We could, of course, if we wanted, use a. In fact, we'll use a. Log to the base a of x cubed. Now, let's think about how we could write this. Log to the base a of x cubed. Well, this is going to be now log to the base a of x multiplied by x multiplied by x. If we consider now using the addition law, we could actually write this and split this up. So what we have here now is a product. We've got a product. So I could write this now as log to the base a of x plus log to the base a of x plus log to the base a of x. So all I've done is used this law of addition now to split it back up. We can see from this that we've got log to the base a of x plus log to the base a of x plus log to the base a of x, which is going to give us now 3 log to the base a of x. Now, whilst that isn't a proof and it's a demonstration with a given scenario, I think it's a lot easier to understand now why the power law, and this is what we call it, works for logarithms. Log to the base a of x to the power of k is k lots of log base a to the power of x. So all we need to do is be able to use and employ that. It's highly unlikely that you'll be expected to show it. So these now are the 5 particular laws that you need to use to simplify logs and just use them, especially when it comes to equations. I'm going to add 2 more for completeness, and the first one is log to the base a of a to the power of x is equal to x. Now this is fairly intuitive, as we can bring now the power down. So if we think we could write this as x multiplied by log base a to log base a of a, which is just going to give us x. And again, if we use now the idea that the log and the exponential are inverse functions, we can write a to the power of log to the base a of x. That will also be equal to x. Now, using and applying these is less frequent, but I've just added them for completeness. What we want to do is focus now on the use of these particular laws. So what we're going to do in this video is work